The story of life on Earth is written not in ink, but in the intricate threads of evolution, a grand narrative of adaptation and survival. And few tales are as masterfully woven as that of the spider and its web. It's a story that begins on the forest floor and ascends into the open air, a chronicle of how a simple silken thread became one of nature's most sophisticated hunting tools. Our journey begins hundreds of millions of years ago, with the earliest spiders crawling on the ground. These ancient hunters didn't build the familiar aerial webs we see today. Instead, they laid down sheets of silk over the leaf litter or in burrows. These primitive webs acted as tripwires and sensory extensions, alerting the spider to the clumsy footsteps of an approaching insect. It was a simple, yet effective, ground-based strategy. But as insects took to the skies, spiders had to evolve. The web began to rise, first as messy, three-dimensional tangle webs, and eventually into the elegant, two-dimensional orb webs that now dominate landscapes worldwide. This leap from ground to air was a pivotal moment, opening up a new, abundant source of prey. These aerial webs are not just passive nets. They are finely tuned weapons. The classic orb web, with its radial lines and sticky spiral, is a masterclass in engineering, designed to absorb the impact of fast-flying insects without breaking. But this is just one design in a vast arsenal. The funnel web spider builds a silken burrow with a wide, sheet-like opening, ready to ambush any creature that wanders too close. The bolus spider, a true specialist, forgoes a web altogether, instead swinging a single line of silk with a sticky globule at the end, mimicking a female moth's pheromones to lure in its male victims. Each web structure is a unique solution to the challenge of catching a meal. The key to this evolutionary success is the silk itself. Spider silk is a marvel of material science. It's stronger than steel by weight, yet incredibly elastic, capable of stretching to many times its original length. Spiders produce a variety of silks from specialized glands. Strong, non-sticky dragline silk is used for the web's frame and for a lifeline. The sticky, elastic capture silk forms the spiral that ensnares prey. Other silks are used for wrapping victims, protecting eggs in a soft cocoon, or even for travel, a process known as ballooning, where young spiders ride the wind on silken parachutes. This diversity in web design and silk usage provides clues to the tangled family tree of spiders. By comparing the web-building behaviors of different spider families, from the ancient Mesothelae who still build trapdoors, to the highly advanced orb weavers, scientists can trace their evolutionary relationship.